Okay, I think okay. So let me there we go. I think like that is good. Okay, hi guys. So in this video, what we're gonna do is we're going to get into actually multiplying. Well, I think we did multiplying the other day. I might just go over a few examples, but mostly dividing rational functions. So before we get into that, I want to just kind of do a little review of dividing fractions, because I feel like that's very important, and they're not really that bad. I mean, this is honestly like dividing fractions. That part is honestly from 8th grade, or from middle school. So let's say we have something like, I don't know, 2/3, right? Let me write that a little bit bigger. So 2/3 divided by 4/5, right? And I know this is probably just a really random example, but the way that it works is that if we have A over B divided by C over D, then that means that, we will have A over B times D over C. So basically A over B divided by C over D equals AD over BC, right? And I really hope y'all can see that. So that's how it works. So if we do 2/3 divided by 4/5, basically, and let me actually, hold on. me actually... Hold on, guys. I'm gonna change the, what is it called? The title of this. So, me. Let me, okay, hold on. I'm gonna change the title very quickly because, so let me see, hold on, let me look at my previous streams, hold on. Give me a second. Because I need to see, okay, hold on, let me change this to part 4 because I don't want to have 2 part 3s. Okay. There we go. Okay. So we can continue. So, and I know this camera, it's not the best camera to record in. But I really hope you can see what I'm writing. That's why I'm gonna be saying everything that I'm writing. Hold on. So if we have something like this, right, 2/3 divided by 4/5, you want to go ahead and, so if y'all remember what keep it, change it, flip it was, right? So, okay, so the first part, keep it, so we're going to keep the 2/3, right? 2/3. We're going to keep it. And then we change this part to a multiplication, so you can do either a dot or times, it doesn't matter. For once we do rational, you would put the dot, okay? Because that's I mean, it's really crucial that you do that because you don't want to confuse your variables and then your multiplication symbols. So then we flip this part, we have 5/4, right? This is going to be, this then equals, so basically we have 2/3 times 5/4, that's 10/12, right? That's what it equals, 10/12, we go ahead and simplify this. We reduce it. So we divide by 2, we have 5, 6, and 5, 6 is our final answer. So that's an example of like how to multiply fractions. We obviously, we understand, or we should understand how to do that by now. Or did I say multiply? I meant divide fractions, excuse me. I don't know if I said multiply or divide. It was, we should know how to divide fractions by now. But now we introduce this topic to rational functions, right? So I'm gonna look for some problems. So let me see, hold on. I need to see the section that I need to go to, so hold on. And this is going to be in chapter 1, only because, obviously in chapter 5 or whatever, it doesn't show us, it does not show us a, what was it called? Like, it does not show us like dividing and multiplying rational functions for some reason. I really don't know why. But it's okay. I'm gonna see. I think it was on chapter 1, if I'm correct. It was on chapter 1. Give me 1 second, guys. Hold on. I'm looking for it. So rational expressions, right? So So I would go over a very simple one. Obviously, in college algebra, they're not going to be that nice. Because I see a bunch of these and I see that a lot of them are pretty difficult. Let me go ahead and see. Maybe, hold on, guys. So obviously with multiplying rational expressions, we're just going to do one very quickly. So let's see here. and it's going to be a pretty difficult one, so please, I really recommend you guys that you pay attention. For whoever watches this, please pay attention. So it's going to be t squared, so let's do this one. T squared minus 1 over t squared plus 4t plus 3 times t squared plus 2t minus 15 over, and then it would be, what was it, t squared minus 4t plus 3, right? So we're just going to do this one very quickly, even though I already did this in the last video that I did, or the last stream. So t squared minus 1, remember that we use the sum, or the difference of two squares pattern. A squared minus b squared equals a plus b times a minus b, right? So then we have t squared minus 1 is obviously t plus 1 times t minus 1, right? That's what that is what t squared minus 1 is, right? Over, and then we do t squared plus 4t plus 3. Obviously, two numbers that multiply to 3 and add it to 4 are 3 and 1, so we have t plus 1 times t plus 3. Now, like I said, do not cancel out anything until you're actually multiplying across. T squared plus 2t minus 15, so two numbers that multiply to 15 to negative 15 and add it to 2 are negative 3 and 5, so we have t minus 3 times t plus 5, right? And then over, and then two numbers that multiply to 3 and add to negative 4 are negative 3 and negative 1, so we have over t minus 3 times t minus 1, right? And then we go ahead and bring it together, so then we have t plus 1 times t minus 1 times t minus 3 times t plus 5 over t plus 1 times t plus 3 times t minus 3 times t minus 1, right? So then we look at this, right? We look at this we look at this equation here, and we see, okay, there's a t plus 1, so we cancel that out. A t minus 1, we cancel that out. T minus 3, we cancel that out. So we're left with t plus 5 over t plus 3, right? So that's our final answer. And that's just one example for multiplying. So it's the same thing with dividing. You're just flipping it over. So I'm not going to do the same problem because obviously this problem was on the textbook specifically for this one. But we're going to do one that's actually division or dividing. So let's see here. And just a little disclaimer, there are some pretty difficult ones. I mean, obviously in college algebra, that's just how it is. This is not really beginning algebra. I wouldn't say. If it was beginning algebra, maybe it would be a little bit easier, but it's not. So just keep that in mind. So so let's see here, hold on. Let me try to see if there's other examples, hold on. Because those examples in the book, they're obviously practice problems. Hold on. So let's do this following one. So we have x squared minus 8x plus 15 over x squared minus x minus 6, right? Divided by x squared plus x minus 20 over x squared minus 6x plus 8. Okay. Hopefully y'all can see that. It's the same thing. We're gonna go ahead and, factor the top and bottom. So before we do that though, we're gonna go ahead and change this. So basically, remember how I said A over B divided by C over D equals A over B times D over C, which is AD over BC, okay? So what we're gonna do, we're not gonna do this part here, but we're gonna go ahead and change it to a multiplication, okay? Because obviously with division, we know how it works, we want to do it so that it looks like multiplication. That way it's a little bit easier to understand it. So basically dividing fractions is just multiplication in disguise, if you think about it. X squared minus 8x plus 15, we go ahead and say, well, two numbers that add to -8 and multiply to 15, they are let's see, they're -5 and -3. So x minus 5 times x minus 3 over, and then two numbers that added to -1 and multiplied to -6 are -3 and 2, so we have x minus 3 times x plus 2, okay? And then times, we're going to flip this part over. So let me just go ahead and change the color a little bit. So we're going to, for this part, we're going to go ahead and change the color a little bit. So we're going to say, just for the purpose of understanding what's changing, so basically we have divided by x squared plus x minus 20, and then over, and then we're going to say me see. Actually, never mind. We're gonna say the bottom part, which is x squared minus 6x plus 8. Okay. I know you guys can't really see the color, but it's obviously it's color-coded. Let me see if I can find a different color very quickly. So let me change this color actually to I'll change it to red. So we have over x squared minus 6x plus 8, right? And let me actually change this one. You know what? I'll go ahead and change this one. Or I'll keep it like that, actually. I'll keep it like that, because, yeah, it's fine. X squared minus 8x plus 15. Okay. So we're gonna change this part, right? And then so we have divided, or we have times. We're gonna, so basically what I'm doing, and I know this is taking a while, guys, but it's because I really want you to understand like how I'm doing this, because it's very important. So hold on. X squared minus x minus 6, and then we have that part. And then the bottom, we're gonna just put the bottom as so. Actually, guys, you know what? Just to make this a little bit easier on myself, because obviously the camera, it's not really that great. Let me go ahead and just do it through OBS, or not OBS, excuse me. What is it called? Let me do it through, I'm gonna just do it through, what is it called? I'm gonna do it through OneNote because I feel like that's a lot easier for you guys to see. Hold on. Give me a second. Oh my goodness. Hold on, guys. Let me... I'm trying to see how I can actually... Hold on. So we're gonna do this instead because I feel like it's just a lot better, especially with because I don't have a proper camera for the what is it called for the give me a second, guys. I'm gonna see how I can actually make it so that... Oh my goodness. How do I do this? Hold on. Yeah, I really don't know how to make it fit the whole screen, but hold on, let me go ahead and, oh my goodness. No, hold on. There we go. Okay. Yeah, I don't know how to make it full screen. That's the only thing. I mean, like, I don't know how to fill it so that it looks, you know, so that it looks better, if that makes any sense. If anybody has, like, any suggestions as to how to do it so that it looks, and then I don't think that this resolution is the best. I really don't know why. Anyways, we're gonna get started. So, the problem I was doing, let me go ahead and just get my pen. Hold on. So, the problem I was doing, let me see. Give me a second, guys. Hold on, I'll be right back. Give me a second, guys. I'm just going to, So it was 1.6, right? So if we look, hold on, let me bring it back. So like I said, obviously the problems on here are very, how do you say it? Like they're very, complex, I would say. Let me look for another, okay. So, okay, I feel like this is a lot better than how I was doing it. So let me go ahead and, let me go ahead and do, so, let's see, hold on. So, we have 5y squared over 3, so we're gonna say 5y squared over 3 times 9x over 10y. Okay. So, and we're gonna multiply it, right? Actually, was it multiply? I can't remember. Actually, let's do, hold on. Well, yeah, we'll do as much as we can of these. Mostly, I'm gonna do, hold on, I'm gonna do 7x cubed over z, actually. Let me just, because I want to do dividing, okay? 7x cubed over z divided by 5z cubed over 3. Okay. Now, we can color code, so we have 7x cubed over z, and then divided by, and then we have 5z cubed over 3, right? This means we're going to have 7x cubed over z times 3 over 5z cubed, right? We're flipping it, okay? So we're going to be flipping it. So from here, if we can multiply it across, because obviously I don't think there's anything that, you know, that gets canceled out, right? So we have 21x cubed, because it's basically 7 times 3 times x cubed, okay, over 5z cubed times z, right? Or we can say 5 times z cubed times z, okay? So then we have 21x cubed over 5z to the 4th, okay? This is what our answer would be. And as you can see, that's what they did. Now, this second one, so if we look at x squared minus 9 over x plus 4 divided by x minus 3 over x plus 4, right? We have, so we're gonna go ahead and keep this the same. So basically, this part here stays the same. So we have x squared minus 9 over x plus 4. We're gonna turn this division symbol to multiplication. So times, and then we're gonna flip this. So this part is gonna be flipped. So we're going to have x plus 4 over x minus 3. Now, one thing to notice, and I don't want anybody to forget this part. Let me just kind of clean my screen a little bit because it's kind of dirty. So one thing to remember about this part is that you have, so x squared minus 9, if we rewrite it, this one here factors as, it's x squared minus 3 squared, right? That means that it's a squared. Basically, it's like this. So it's x squared minus 3 or let me actually, hold on, minus 3 quantity squared, right? So we have, this simplifies as, it's going to be, so it's going to be, this part is basically like this, a squared minus the quantity b and then quantity squared, right? So then you want to go ahead and you know, this basically simplifies to something like this. So it's the quantity A plus B times the quantity A minus B, okay? And I know this is very slow, guys, I know, but I really want to make sure that we understand this very, very well. So basically, this, so therefore, we have the quantity x plus 3 times x minus 3, and then divided by x plus 4 times x plus 4 over x minus 3. This gives us the quantity x plus 3 times x minus 3 over x plus 4 times x plus 4 over x minus 3 without color coding, and then this gives us, we just bring it together, so it's going to be x plus 3 times x minus 3 times x plus 4 over x plus 4 times x minus 3, right? So then, once you do that, you see that these two are common, or these four rather, so you go ahead and cancel them out. So you're left with x plus 3. Now if they asked for the domain, if let's say you want to find the domain, right? This is just going to be added in, so the domain would be all real numbers such that x does not equal 4, or excuse me, negative 4. So basically, all real numbers such that x plus 4 does not equal 0, x minus 3 does not equal 0, right? And then you would say, so basically x plus 4 does not equal 0, x minus 3 does not equal 0. So you subtract 4 on both sides, you get x does not equal negative 4. And then you add 3 to both sides, you say x does not equal 3. So therefore, the domain is, so if we kind of draw a number line or a line, right? We can say the domain is, that's negative infinity. This is positive infinity, right? So we have the domain goes from, so our points at which we cannot cross, we have -4 and 3, right? They're open circles because we cannot cross them. And it's all the real numbers such that x does not equal -4 and x does not equal 3. So that means that in interval notation, the domain is going to be from negative infinity to -4, parentheses, union -4 to 3, union 3 to infinity. Okay, and that's if they were to ask, like, what is a domain, right? But of course, that's not what the question was asking, so it's fine. But I really just want to, I really want to make sure y'all understand, like, the basics of, like, of what this, you know, kind of make sure we understand what domain is. But I'm not going to do this for every problem, but yeah. Let's look at another problem. So as you can see, they got x plus 3, and that's what we got over here, right? Let's do another one. We have x squared plus 8x plus 15 divided by x squared, or over x squared divided by x plus 3 quantities squared, okay? Now, you can rewrite this as the following. So, you can do like a little following like this, right? X plus, so if we factor x squared plus 8x plus 15, we have 1 and 15, which is 15. We have our middle term, which is 8. Two numbers that multiply to 15 and add to 8 are 3 and 5. So our factors end up being x plus 3 times x plus 5, right? So we have x plus 3 times x plus 5 over x squared times 1 over, and this really is, I mean, if you think about it, we can actually rewrite this as divided by x plus 3 times x plus 3 over 1, right? Because it's just x plus 3 squared, right? There's just, anytime you see a whole number, it's like if I said 2/3 divided by 5, that's just equal to 2/3 divided by 5 over 1, which is equal to 2/3 times 1 over 5, which is 2/15ths, right? It's the same idea here. You're just putting a denominator of 1 to make it kind of like, to make it kind of, easier, you know, to understand what they're trying to do. Sorry guys, give me a second. So, okay, so then, what you're gonna do is you're gonna go ahead and keep it, change it, flip it, right? You have x plus 3 times x plus 5 over x squared times 1 divided by x plus 3 times x plus 3, right? You're just flipping it. And you're changing the division to multiplication. So basically keep it, change it, flip it, right? And so basically that's just how it is, and you go ahead and you do this, and then you say, okay, you bring it together, you say x plus 3 times x plus 5. Since there's a times 1, we're just going to keep it that way, over x squared times x plus 3 times x plus 3, right? So then that gives us x plus 5 over x squared times x plus 3. Notice that we cannot simplify it any further, so we're just left with x plus 5 over x cubed plus 3x plus 3x squared, right? Or you can leave it like this in factored form. They're both the same. They're both right answers, okay? So, if we look at the problem, as you can see, they got x plus 5 over x squared times x plus 3. I mean, you can, like I said, you can leave it in factored form, that's fine. But, you know, I would always just put both. Unless it's multiple choice, and you would have to look for the right one they're looking for. So, let's see here. Okay. Okay, hold on, guys. Sorry, let me go back. So that's just how you do it. Now, let's see. Now I want to do a little, like, you know, a little review of multiplying and dividing rational functions. We obviously already did the first one, right? The second one, we're going to just do it. So we have 2x cubed y over 3z to the 4th, so times 6xz to the 5th over 10 y to the 5th, right? So, since this is not really like, so basically you can forgot to spell across. Oh my goodness. Hold on, guys. Now, if you don't remember what a monomial is, what I mean by this is that you can only multiply across if you have something like, if you only have one term. So remember that a monomial is like 2x, 2y, y, z, w cubed, z cubed, x cubed, y cubed, dot 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 dot. A binomial is like x plus 2, x plus 1, 2x plus 3, 3x plus 4, 5x minus 7, 2x squared plus 5x, dot 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 dot. A trinomial is x squared plus 2x minus 7, 2x cubed minus 3x minus 6, x cubed minus 3x minus 1, x squared minus 4x plus 5, and x cubed minus 7x minus 10, dot 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 dot. It goes on forever. Like the list. So these are monomials. They have only, I mean, they only have, they don't have really like, what I'm trying to say is they don't have an addition in the middle. So when it's not being added to something else. So we just have 2x cubed y over 6xz to the 5th. Now what you can do is you can go ahead and say, well, this is 2 times x cubed times y times, and then you can do a little like, you know, like you can say that's 6. If we color code, you can say that 6 is just 2 times 3, and then times x times e to the 5th over 3 times z to the 4th. And then you can do the same thing with 10. You can say that 10 is, let me actually, you can say that 10 is 2 And let me... Two times 5, and then you can say that y to the 5th is just times y to the 5th, right? This then gives you... So you can cancel out the 2's, right? You have a 2 right here, a 2 right here, so you can cancel those out. And then you have a 3 over here, a 3 over here, so you can cancel those out. You have, let's see. Now, as far as the z's go, and like the z to the 5th, the z to the 4th, the y and the y to the 5th, the x cubed and x, I mean, you can go ahead and say now x cubed times x times y times z to the 5th, right? Times 2 over z to the 4th times y to the 5th, right? This gives you x cubed times, and we can say z to the 5th over z to the 4th, that's just z to the 4th times z, and then the x stays there, the y stays there, and the 2 stays there. So basically we have, so that we can cancel out the z to the 4th, right? We want to do that. So we have times z to the 4th over y to the 5th. Now y to the 5th, this can be rewritten as, so we can rewrite this as the quantity y times y to the 4th, right? That's what this part would be. And then we can cancel out the y, so then we have x to the 4th, z to the 5th, times 2 over z, or sorry, hold on, give me a second guys, hold on, I forgot to do something. So the z to the 4th, these cancel out, so then we're left with x to the 4th times, because basically we have x cubed times x times z times 2 over y to the 4th, right? That's what we're left with. So then we have 2 x to the 4th z over y to the 4th. So this would be our final answer. Now, I know that was a very, very, very long explanation to all of this, but you know, that's the more detailed way to do it. The shorter way to do this, honestly, if you are very good at doing your exponents, like all of that good stuff, if you know how to do it very well, we can say 2x cubed y over 3z to the 4th times 6xz to the 5th over 10y to the 5th. This is kind of the more advanced way to do it. So we have 12 x to the 4th yz to the 5th over 30 z to the 4th y to the 5th. Okay. Now this means that we're going to have 12 over 30 times y over y to the 5th times z to the 5th over z to the 4th, right? And then times x to the 4th over 1. So then we have, remember that, so 12 over 30, that's just, if you reduce that, oops, that's just 2 over 5, right? So then we have, and then y over y to the 5th is, that's just y over y times y to the 4th, which is 1 over y to the 4th, right? Z to the 5th over z to the 4th, that's just z, and then x to the 4th over 1 equals x to the 4th. So we have 2 fifths times 1 over y to the 4th times z times x to the 4th. So then we're going to have 2 x to the 4th z over 5 y to the 4th. Oh, I forgot to multiply the 5 here. My bad, guys. Should be like this. So yes, you would get the same answer if you did this. So it's your choice which one you want to do, like which method you want to do it. But yeah, I mean, honestly, it's, you know, if I were you, I would prefer using this method when we have monomials, just because it's a little simpler. It's a little bit easier to simplify when you have everything together. Because then when you split it up, it just takes longer, and versus doing all of this, like all of this work here on the top, versus doing this, it's a lot simpler, or it's a lot shorter. So we're going to go to the next one. We have, let's see. We have so let's see here. Now, if you can simplify the fractions, go ahead and do so. 9y squared over 8 cannot be reduced further. So we just leave it as 9y squared over 8, and then 32. So basically, however, 32 x over 27y can or wait, can it be simplified further? Now that I think about it, I don't think so. Hold on. I don't think so. 32 over 27. No, I don't think it can. Never mind. My handwriting is terrible, guys. I'm sorry. Cannot be simplified further. So we have 32. So basically we have 9y squared times 32x over 27y. This gives us, so we can just bring it together, 9y squared times 32x over, and let me make sure my microphone, okay, good. 9y squared times 32x over 8 times 27y. Now again, you can multiply them across if you want, like you can do that, but then you have to make sure you reduce it. So there's two ways you can do, just to not confuse yourself. The way I would do it is I would just multiply across. So I would say this is 32, so 32 times 9 is 288, so it's going to be 288 xy squared over, and then 27 times 8 is 20, so basically 216, right? I mean, honestly, if you really don't want to do it this way, there are other ways. So basically, you can say 9y squared times the quantity, and let me highlight it just to make sure. So basically, we're going to have the following. 4 times 4 times 2 and I can say the 9y squared is 3 times 3, right? So basically, I can say that the 9y squared is 3 squared, right? The 4 times 4 times 2 is 32, right? And times x, right? Over, and then I can say the 2 times the 8 is just 2 times 4, or rather 2 times 2 times 2, right? Over, and then, or rather times 3 times 3 times 3, okay? Or 3 cubed if you want to write it that way. So this one can be this part. And then times y. So, oh, and then the times y, so basically up here, times y times y. So basically we have this part is this part, and then let me go ahead and change this color to this, and then I'll change the X to this color. So basically we have 4 times 4 times 2 times x times y times 3 squared. And then we're going to go ahead and divide all of that by the bottom. So then we have the y part is just this part here. So now we can go ahead and do a little bit of, you know, of simplifying. So then we have 3 squared, so we have 3 squared. We can rewrite that as 3 times 3 times 4 times 4 times 2 times x times y times y. Actually, the 4 times 4 times 2, this can be rewritten as 3 squared times 2 times 2 times 2 times 2, right? And then times 2. That's this entire purple part, okay? Times x times y over 2 times 2 times 2. So basically, and then times 3 times 3 times 3. I mean, it really helps when you really simplify it all the way, because that way you know what to cancel and what is remaining. And then times y, right? So then this cancels out. These 3 cancel out. This one, and then this one cancels out. So we're left with 2 times 2 times x times y over 3. Right? As you can see right here, yes, it's 4xy over 3. Number 4, let's see, hold on. 2x squared y over 3z cubed. So basically we have, let me go a little bit faster now that we've done a few of these. So hopefully hold on, so times 12x(z to the 4th) over 6y cubed, right? This is 2 times, so basically we can just go ahead and simplify across, or multiply across. We have 24x cubed yz to the 4th over 18 z cubed y cubed, right? This gives us 24 over 18 times x cubed over 1 times y over y cubed times z to the 4th over z cubed. This gives us, you simplify this, 24 over 18. When you simplify it, you get 4 over 3, right? So it's going to be 4 over 3 times x cubed, y over y cubed, that's just y over y times y times y, which cancels out, times z to the 4th over z cubed, that's just z, right? We have 4x cubed over 3 times 1 over y squared, and z to the 4th over z cubed, remember, that's just z to the 4 minus 3, which is z to the 1. That's why I put z. And then times z, okay? So then we have 4x cubed z over 3y squared. And that's your final answer, right? The fifth one, three y squared over 5 times 10x over 15y. Now again, you can go ahead and multiply across, or you can go ahead and do, so basically we have 3y squared over 5, and then 10 over 15, that can be simplified. If we do 10 over 15, we reduce it by dividing by 5 on top and bottom. We have 2/3, right? So we're going to say 2/3 times x over y. So we're going to have 3y times 2 times x over 5 times 3 times y. Okay? We cancel them out. Cancel the 3 out, cancel the y out, and then we are left with 2xy over 5. Okay? Three y squared over, or actually, hold on, no. 4x squared y. I don't know if I actually did some of these. I feel like I did, but I don't know if I did for sure. Hold on. Okay. Let me just skip number 6. I'm gonna go ahead and do number 7, okay? This one's interesting. X plus 4 divided by 3x plus 4y. Oops. Times 9x squared minus y squared. So over, and then we have 2x squared plus 3x plus 1, right? Now, this one's a little bit more interesting. We can factor, so number 1, factor 9x squared minus y squared. This is interesting because, you know, obviously, yeah, I mean, this one's very interesting. Remember that this is A and then this is C, so we have negative 9x squared y squared, right? And then our B is 0, so then we're left with negative 3xy and 3xy as our values, right? So then we have to do we do the box. We have 9x squared, negative 3xy, and negative y squared, right? 3x, right? That's what equals 9x squared. And then we have times negative y for negative 3xy. And then y times 3x is what gives us 3xy. And then y times negative y gives us negative y squared. So then this factors as, so then we have x plus 4 over 3x plus 4y times 3x minus y over 3x plus y. This gives us, so basically we have oh my bad. 3x, it would be 3x plus y times 3x minus y divided by 2x squared. So then the 2x squared plus 3x plus 1, we can just leave it like that for now. We are going to factor it. So that would be the second part, factor 2x squared plus 3x plus 1. So then we have 2 times 1, that's 2. The 3 is with the middle part, goes on the bottom. So then 2 numbers that multiply to 2 and add to 3 are obviously 2 and 1. Now we go ahead and do our box. The ax squared part goes on the top left, 2x squared. The first factor, 2x, goes here. Second factor, x, goes here. And then the c part goes on the last square. So then we have 2x and x, and then we have 2x and 1, and then 1 times x is x, 1 times 1 is 1, so then we have the following. So thus, we have x plus 4 over 3x plus 4y times the quantity 3x plus y times 3x minus y divided by 2x plus 1 times x plus 1. I mean, you can, you know, obviously since there are no factors that really cancel for this, at least I don't think, You can leave it in factored form. Let me see how they did it, actually. Because I'm not completely 100% sure how they actually put it. Interesting. Interesting, okay. Or number 9, excuse me. It was number 9, not number 7. It was, hold on, let me see. Which one was it? It was x plus 4, so... Or yeah, no, it was number 7. X plus 4. Oh. Oh, oops. My bad. I was mixing them up. My bad, guys. Oh my goodness. Let me do that again. Oh. I am so sorry. Oh my goodness. Let me... Hold on. I mixed them up. Let me do it again. So... Okay, so it was... Hold on, it was... x plus 4 over 3x plus 4y times 9x squared minus 16y squared over 2x squared plus 3x minus 20. Okay, so we're gonna factor. We are gonna factor. We're gonna factor specifically these two, okay? So 9x squared minus 16y squared, that's equal to, so basically we have, if we do our x box, 16 times 9, I'm trying to think, that's, how much is that? What was it? It was, okay, hold on, it was 9 times 16, so let's see here. 144. Negative 144 specifically, x squared, y squared. Oops. So then two numbers that add to 0 and multiply to negative 144 are negative 12xy and 12xy. So basically the bottom should be 0. So then we have the following: 9x squared, negative 12xy, 12xy, and negative 16y squared, right? So then we have 3x and 3x, and then we have 4y times 3x, we have negative 4y times 4y, which is negative 16y squared, and 3x times negative 4y is negative 12xy. So this simplifies as 3x minus 4y times 3x plus 4y, okay? That's how we would write it, right? Right, and then you would factor, so then the second part, you would factor. So basically the first part would be factor. It would be factor that, and then the second part would be factor 2x squared plus 3x minus 20. You do your x box. You get 2 and negative 20, that's negative 40. And then you get a 3, and then you have, so basically it would be, so two numbers that multiply to negative 40 and add to 3. Oh boy. It's going to be negative 5 and 8, right? So you put your 2x squared right here, your ax squared, your first term negative 5x, your second term 8x, and then your third term, which is negative 20 right here. So then it'd be 2x times x, and then 8 times x, right? Actually, let me switch these, hold on. So it'd be x and 2x, and then x and negative 5, 4 and 2x, and 4 and negative 5. So then it would be 2x squared plus 3x minus 20 equals 2x minus 5 times x plus 4, right? So then right here we would have two x minus 5 times x plus 4. Now notice that there are things that cancel, so you have x plus 4 times 3x plus 4y times 3x minus 4y over 3x plus 4y times 2x minus 5 times x plus 4. So then you would go ahead and cancel these out. You would cancel this stuff out. So then you are left with 3x minus 4y over 2x minus 5. Right? So, I mean, all in all, I think that, you know, multiplying is should be something pretty easy. Now we're going to get to dividing. So, let's do some simple ones. U to the 5th x, so we have, this is number 32. U to the 5th x over y times, divided by ux squared, so ux squared over y to the 4th. So basically, you're going to do the exact same thing we did, so then we have u to the 5th x over y, you're going to keep this part, you're going to change this to a multiplication, and you're going to flip this over. So this stuff is going to be flipped over. So you're going to have y to the fourth over u x squared. Now this gives you u to the fifth times x times y to the fourth over y times u times x squared. So then this gives you u to the fifth over u times x over x times x times y times y cubed over y, right? So then you have u times u to the fourth over u times, this stuff cancels out, so you're going to have 1 over x, and then this part cancels out, so you're going to have y cubed. So then this gives you, this also cancels out, so then you have u to the fourth times 1 over x times y cubed. So then it's going to be u to the fourth y cubed all over x. And that would be your answer. Okay. We're going to do, let's see, we're going to do 28p squared q to the fourth, so over 1, let's just put over 1, or let's do it how it looks, divided by 4p q to the fourth over 5r. So this, again, there's two ways you can do it. You can simplify the numbers so that they are in short terms. Basically, we can say 28 is 7 times 4, right? We can say that. So this times p times q to the fourth over 1 and then times, we're going to flip this over, 5r over 4pq to the fourth, right? Except, well, yeah, it would be 4pq to the fourth. Because obviously we already have a q to the fourth on the top, so we wouldn't have to simplify it so that the top and bottom are the same. So we would just have 7 times 4 times p times q to the fourth times 5 times r, and then over 4 times p times q to the fourth. So then we have these parts canceled out. This one, and this one. So then we are left with 7 times 5, that's 35. And then times r, that's just r. So this is our answer. 35r is what it would be. Okay, so now let's look at some difficult ones. 3x squared plus 4x plus 1 over 3x squared minus 5x minus 2 divided by x squared minus 2x minus 3 over negative 5x squared plus 25x minus 30. Right? Plus 25x minus 30. So if we look at this one, we have, so we're going to factor 3x squared plus 4x plus 1. That's our first step. We're going to do Xbox method. So basically this is A, this is B, this is C. So A times C, 3 times 1 is 3. And then we have the 4 on the bottom. Two numbers that multiply to 3 and add to 4 are just 1 and 3. So then we have 3x squared, x, 3x, and 1. Because that's basically we have 1x and then 3x, right? I mean, you can do it this way if it helps. You know? So then we have x and 3x, because then we have to multiply over here. So then so basically x times something is x, so it's going to be 1. And then 1 times 3x is 3x, and then 1 times 1 is 1. So then we would have the following. If, let's say, this was color-coded, right? This would be 3x plus 1 times x plus 1. Over 3x squared minus 5x minus 2 divided by x squared minus 2x minus 3 over negative 5x squared plus 25x minus 30, right? So then we're going to go ahead and do this part now. So we have so then factor 3x squared minus 5x minus 2. This will give us so basically we have 3 and negative 2, that's negative 6x squared. And then on the bottom would be negative 5x. And then we have negative 3x. Hold on. That almost tricked me. Negative 6x and x, right? That would be the way to do it. And then you would have, so basically we have our box, right? Our box. 3x squared, negative 6x, x, and negative 2, right? X, we would have 3x and x, right? 3x times x is 3x squared. 1 times x is x. 3x and negative 2 is negative 2x. and 1 and negative 2 is negative 2. So then this would factor as the following. And we can color code this again. So let me grab this part and just color code it. So we have be like this, right? So then we'll have the following. So obviously it would be 3x plus 1 times x plus 1 over x, or 3x plus 1 would be 3x plus 1 times x minus 2, and then times, or sorry, divided by x squared minus 2x minus 3 over negative 5x squared plus 25x minus 30. I know I'm going very slow with this, guys, but I really want everybody to understand how this works. So then we're going to go ahead and color code this part. X squared minus 2x minus 3. Now the good thing about this one is that we don't have to do box method. Just two numbers that multiply. So basically we have two numbers that multiply to negative 3 and add to negative 2 are just, basically it's going to be negative 3 times 1, which is 3, and negative 3 plus 1 equals negative 2. So then we have x minus, or x plus 3 times x minus 2 for this part, right? So then we have, so then we would have the following: 3x plus 1 times x plus 1 over 3x plus 1 times x minus 2 divided by, or yeah, it would be divided by, and then it would be x squared. So it would be x plus 3 times x minus 2 actually, hold on. I did that wrong. It'd be negative 3 and 1. So basically, sorry, I meant to say, this part is x minus 3 times x plus 1. Yes. My bad. It's x minus 3 times x plus 1. And then over negative 5. And we're gonna factor out a negative 5. So we're gonna have negative 5 times x squared minus 5x plus 6. Okay. So then this part here factors as two numbers that add to negative 5 and multiply to 6 are negative 3 and 2, or negative 3 and negative 2. So it'd be x minus 3 times x minus 2, right? So then you'd have the following: 3x plus 1 times x plus 1 over 3x plus 1 times x minus 2 times, or divided by, x minus 3 times x plus 1 over negative 5 times x minus 3 times x minus 2. And finally that we've factored everything, we are done factoring everything that we already factored, we can finally do the keep it, change it, flip it rule. Right? This would be 3x plus 1 times x plus 1 over x plus, or 3x plus 1 times x minus 2, and then times, and if you want, you can cancel these out, but I wouldn't do it until the end, just so that you don't confuse yourself. You can, but, you know, it's always better to do it at the end. And this should go here. Times x, or it's going to be times, and this is going to be flipped over, so flip. So then we have negative 5 times x minus 3 times x minus 2 over x minus 3 times x plus 1. And now we go ahead and bring it together. So basically, we want to bring it all together. So we have 3x plus 1 times x plus 1 times negative 5 times the quantity x minus 3 times x minus 2 over three x plus 1 times x minus 2 times x minus 3 times x plus 1. So then we have the following. We cancel these out, cancel this out, cancel this out, cancel this out. So our answer ends up being negative 5. Okay. So yes, these problems can be pretty long, but it's because, you know, once you get to like calculus and pre-calculus and stuff like that, you'll find that a lot of problems are very long. So it's something to get used to if, you know, especially if you're gonna be studying math in the long run for anything that you want to do. But that's why I make these videos, that's why I do this, so that I make it a little bit more understandable, and so that y'all can follow along with me. So now that we've understood division and multiplication, now we can finally get to rational equations. And hold on guys. So rational equations are just like when we did polynomial factorization, polynomial equations, polynomial long division, you know, arithmetic with polynomials. It's the same thing with rational equations. There is no escaping it, I guess. So rational equations are very interesting. The idea is to get all your, to get your denominators the same, yes, get all your denominators the same. Hold on, let me, let me go ahead and do on here. Let me look for some examples because I need to look for some. So we're gonna go very simple, okay? We're not gonna go ahead and do like a really tough one all of a sudden. But we're gonna try to be a little bit simple at first, okay? Let's say we have say we have 5 over x minus 1 over 3 equals 1 over x, okay? And you want to make sure, so the goal here is to make denominator equal. Make the denominators equal. Here, obviously, obviously you can do subtraction with this and then make it equal to this and, you know, do cross multiplication and do all that good stuff. But there's an easier way to do it. You know, I feel like if you try to subtract whatever's on here, it's just gonna make it more complicated. So I wouldn't go that route. I wouldn't, you know, one thing that I would not try to do is subtract it out on the left side and then, you know, even though this problem is easy, there are gonna be ones that are gonna be a lot harder. So I don't want you to do that for every problem because, I mean, honestly, like, you know, obviously, it wouldn't work, you know, it's just not convenient to do that. So I'm looking at this and I see, well, there is 2 x's here, you know, there's 2 x's right here, and right here, and there's a 3 here, and we want to make it so that it's the same as these x's, but then I'm like, how do you do that? Well, obviously, you wanna, I mean, I wouldn't, how do I say this? I wouldn't just go ahead and make all of these 3, like, make it 3x squared, for example. Because it doesn't have to be that grand. But I would say, okay, the greatest one that we have, if we have 3 and x, we can say, okay, well, we can do 3x, right? This can also be 3x, this can also be 3x, because obviously, like, even though it's not really, it's not, so basically the way I'm gonna do this, if we have 3 and x, I say, okay, well, if we have 3 and x as our terms, what can we do to make them so that they're both, like, equal? I can say 3x, right? So I say, okay, if I say 5 over x, so let's say 5 over x equals something over 3x, right? And then I say, okay, minus 1/3, that's equal to something over 3x. And then I say, this is equal to 1 over x, and that's equal to something over 3x. So my point here is you want to make it so that you can say, okay, what is this? What is the number that, you know, and if you really want to, you can go ahead and subtract, add, whatever, but know that it's going to make it a little bit harder. Just keep that in mind. So if we look at this, I can say, okay, well, I can say this is 3 times x, this is x times 3, so then this is 5 times 3, this is 1 times x, so now I have the same denominator. I have, and then this one is x times 3, and this one is 1 times 3. So now I have the same denominator. So then we have x times 3, 5 times 3, right? That's 15. And then I have 3 times x, 1 times x, that's x, and then x times 3, 1 times 3, that's 3, right? So then we have 15 minus x over 3x equals 3 over 3x. Now, if they have the same denominator, you can simply say 15 minus x equals 3x. Because either way, they're going to be canceled out anyways, right? You know, if I go ahead and because then if I go ahead and try to do something like this, where I'm like, oh, well, you know, 3x times 3 equals 3x times 15 minus x. It's going to make it harder. It's going to make it longer. So we don't really want that. We want to just say, okay, 15 minus x equals 3. Or sorry, it's 3. My bad. So then, you know, obviously it would be like 3 times 3x equals 3x times 15 minus x. You can do that. I mean, but then it's like, it wouldn't make sense. Like, it's just gonna make it more complicated if you do that, right? So you want to go ahead and just you want to go ahead and just, you know, and just, how do you say it, like, make it as simple as you can. Do not overcomplicate it. You're going to do minus 15 on both sides, and then you're going to have negative x equals 3 minus 15, which is negative 12. You're going to divide by negative 1 on both sides. So then x equals 12, right? Now you can go ahead and check it. 5 over x minus 1 over 3 equals 1 over x. And then doing so, we have 5 over 12 minus, and we're going to go ahead and multiply times 4 on top and bottom so that to make it the denominator equal. So it's going to be minus 4 over 12, which is equal to 1 over 12. So then we have 1 over 12 equals 1 over 12. So then, yay, we have our answer there, right? So then we have 1 over 12. So then that would be our answer, right? Now, another one would be, I'm trying to see if maybe, I'm trying to see if maybe there's some that, like, where it gives us the rational equations, like the whole lesson for that. If not, it's fine. I mean, I don't know why this book, it's like, I mean, I would assume that they would go over this again in rational functions, but I guess not. Hold on. Let me... Hold on, guys, I'm looking. Because I know that definitely there has to be... There has to be, like... What is it called? Rational equations in here. I mean, at least that's what I thought. I mean, I didn't think that, I didn't think that they wouldn't go over something like this. Okay, here we are. Here we go. Perfect. I mean, they only go over, like, maybe a few. Or maybe one, but... Oh my goodness. Hold on, guys. Those are inequalities, they're not equations. Hold on. Okay, no, that's not what I wanted to do. Let me just look them up. I'm gonna look up... So let's look at this one. 7 over 3x. So... plus 4 over 6x squared equals 5 over 8x minus 2 over 3x squared, right? Oops. So then we have 7 times 6x squared plus 4 times 3x over 3x times 6x squared. We can go ahead and do that. When you have something like this, it's like I said, if they're single terms, it's okay to, like, just go ahead and, you know, if you don't have to factor it, then yes, go ahead and do, you know, go ahead and do this, right? But if they're like, you know, and if they're like polynomials or something, then you want to make sure and go ahead and, like, excuse me, you want to make sure and go ahead and factor them if they're polynomials. So, on the right side, this is 5 over 8x plus the quantity negative 2 over 3x squared, right? This gives us, so basically we have 42x squared plus 12x over 18x cubed equals 15x squared minus 16x over 24x cubed, right? And then from there, we can factor, so we have 6x times 7x plus 2, right? And then over 6x times 3x squared, right? Equals, and then we have, in reality, this, we can't really do anything with that. So, I'm using the rule where it says a over b plus or minus c over d equals ad plus bc over bd. That's the rule I'm using, in case anybody's wondering. So we have equals 15x squared minus 16x over 24x cubed. And, I'm trying to think if, I don't think the top is factorable. I mean, it is, but you would do, so basically, you would do something like this, where you say 6x times 7x plus 2 over 6x times 3x squared equals x times 15x minus 16 over x times 24x squared, right? These cancel out, this cancels out, so then we have 7x plus 2 over 3x squared equals 15x minus 16 over 24x squared. Right. Let's see here. This one's interesting. Oh, I see what they did. Okay. Okay. So we can do the following. 3x squared times 15x minus 16 equals 24x squared times 7x plus 2. And then we have, we do distributive property, we have 45x cubed minus 48x squared. So equals 24 times 7, that's what? (168x cubed plus 48x squared. So then we go ahead and subtract, so we can subtract 45x cubed on both sides, and then add 48x squared on both sides, right? This gives us negative, or not negative, it's going to be 123x cubed plus 96x squared equals 0. So then that means that 0 equals x times 123x, or sorry, x squared. It's going to be x squared because we want to factor out the least common, the common monomial factor. So it's going to be x squared times 123x plus 96 equals 0. So that means that x squared equals 0, or 123x plus 96 equals 0. And then we would say x equals 0, or, and we subtract 96 on both sides, we get negative 96 equals 123x divided by 123 on both sides, and that gives us, if we simplify this, I believe it's negative 32 over 41, if I'm correct. Yes, perfect. So this then gives us so we have negative x equals negative 32 over 41, and we can check both solutions. So looking at this equation, we have 7 over 3 times 0 plus 4 over 6 times 0 squared equals 5 over 8 times 0 minus 2 over 3 times 0 squared. So notice that we get 7 over 0 plus 4 over 0 equals 5 over 0 minus 2 over 0. That's like saying that 7 plus 4 equals 5 minus 2. Or it's like saying that, like, what I'm trying to say here is that when we have something like this, it's not going to be a solution, okay? If you put, like, if you put this on the calculator, it's gonna be like saying that there's an error or something. I think that's what it's gonna be saying. So you can't have x equals 0 on the bottom ever, like ever, because then it's gonna make it not true. It's gonna make it undefined. It's not even gonna make it a true statement, you know? So the only one that we have as our solution would be x equals negative 32 over 41, right? we're going to do the second one. X plus 3 equal over x minus 4. So x plus 3 over x minus 4 equals x minus 5 over x plus 4. Right? So we're going to do cross multiplication. So if a over b equals c over d, then AD equals BC. That means that x plus 3 times x plus 4 equals x minus 5 times x minus 4, right? So then we have x squared plus 4x plus 3x plus 12 equals x squared minus 4x minus 5x plus 20. So then we have x squared plus 7x plus 12 equals x squared minus 9x plus 20. So then we have, now keeping that in mind, it's very easy because now we have a linear equation. We can subtract the right part, so we have minus x squared plus 9x minus 20. We can set it equal to 0. Right? So then this cancels out. 7 minus 9x is negative 2x. 12 minus 20. Or sorry, hold on, it would be... Hold on, guys. Sorry, it would be plus 9x, sorry. I was thinking subtracting rationals, but no. 16x minus 8 equals 0. So then we have plus 8 on both sides. And then we have 8 equals 16x over 16 on both sides. X equals 1/2, I think. So then if we try to, and I think this is the last one that I'm going to do for this stream, and I'm just going to pick up later because my laptop's about to die. But we have 1/2 plus 3 over 1 over 1/2 minus 4 over 1. Is that equal to 1/2 minus 5 over 1 over 1/2 plus 4 over 1? This is 1 times, it's going to be 1 plus 2 times 3 over 2 over 1 minus 2 times 4 over 2. Is that equal to 1 minus 5 times 2 over 2 over 1 plus 2 times 4 over 2. So then it's like, so then it would be 1 plus 6 over 2 over 1 minus 8 over 2 equals 1 minus 10 over 2 over 1 plus 8 over 2. So then it would be 7 over 2 over negative 7 over 2 equals negative 9 over 2 over 9 over 2. So then this cancels out, becomes negative 1. This cancels out and it becomes negative 1. So then yes, it is a true statement. Okay guys, so that concludes this stream. I mostly did multiplying and dividing rational functions, so I might pick up tomorrow on rational equations, or I might pick up later, who knows. But I really hope this helps, guys. And I did it through OneNote this time because I know that through the board, the whiteboard, it's very difficult to see. But please do like, comment, and or subscribe, and I will see you guys later. Thank you so much for watching, guys, and have a good one.